First off, thank you for joining us today. This is the first of what's going to be a monthly series of webinars from the One Water Solutions Institute here at Colorado State University. Today, we're going to be diving into a little bit of the background and the methods and the data sets and the conclusions you can draw out of one of our web-oriented dashboards. This one's called the Non-Point Source Prioritization Dashboard. We'll go into what all that means here in just a moment. But thank you for joining us. We appreciate your time. Feel free to interrupt with any sorts of questions that you have. I think you should have the ability to unmute yourself or raise your hand, and I think Sarah can unmute you. Submit any questions that you have to the Q&A section as opposed to the chat. It's just easier to keep track of all those as they come in the Q&A section than in the chat because they can get lost. And we will go ahead and dive right in. So today I'm going to tease you with exactly what you can get out of this, but basically the purpose of the non-point source prioritization dashboard is to prioritize watersheds in Colorado. So you can take a set of metrics and you can analyze them. You can say, okay, which one's the most important watershed, which one's the least important watershed for things like health, things like vulnerability, things like protection, things like restoration. So the goal is to really dive into how do you arrive at this sort of conclusion out of the dashboard. These are all screenshots from the tool. We can do a demo at the end after the presentation. But the point is, how do you get to that point? And what do you use the tool and what are the assumptions built into it? So first, I'd like to highlight our sponsor of today's webinar, the Colorado Department of Public Health and Environment's Water Quality Control Division. We've been working with them for the better part of a decade on a number. I think we're somewhere in the 15-ish range of dashboards for them for different manners of water quality, watershed assessment tools that we've put together. And are very excited that they're collaborating with us on a subset of these OWSI webinars that are probably going to come out just about every quarter. So you can think of that every 3 months. You'll have one that's specific to them sponsoring a tool versus just other projects that OWSI has. To that end, just kind of a highlight of some of the things that exist out there, and you can kind of mark your calendars or pay attention to our email blasts. We have a number of them out there that are going to be scheduled in the near future. We're working on the second one today, the Watershed Prioritization Dashboard, NPSPD. But we have a number of different tools that we've worked with the state to build over the years, including just watershed assessment, TMDLs, stream impairment assessment, lake impairment assessment, economic feasibility, DPA resources, water quality planning scenarios, and statewide water quality management plan. That one's going to go live later this year, but a whole bunch of them. So to start off, these are web software. So what does that mean? You see the icon up in the top right. That is Catena Analytics. That's us. Catena Analytics is the platform on which we develop most of our software. And we can go into the details of the behind the scenes of all the different meanings in the software land. But the point is that there's basically an ERAM's cloud infrastructure that runs on Docker and Kubernetes and a bunch of different languages like Python and Java and some of the databases like Mongo. And these use a number of different libraries for compute services and GIS services. And we've built a number of different data services into them on the compute side. These are things like MCDAs, multi-criteria decision analysis. I'll go into that one a little bit later. It also is things like data sets, right? I want land cover data set from the National Land Cover Dataset, NLCD, or I want climate data, or I want soil data from USDA's Surgo soil data set, and a number of others. What we do is we bundle those together and front face them with a dashboard, the GIS side of it, that is the non-point source prioritization dashboard, that is the RAP tool, that is the SQUIMP tool, that is all the other ones there. So that's kind of the high level of what is the Catena Analytics platform. Each one of these has a very different implementation on the inside, but you can think of it kind of as you get to see the top left of this diagram from your smartphone, from your tablet, from your laptop, from your desktop. You get access to the non-point source prioritization dashboard. That is a web interface that's a mix of Django, React, and Redux that renders websites. To those of you that care behind the scenes, there's actually a number of different resources that we have. This summary is specific to this tool, both internal and external to us, and then some calculation engines on top of that help us interact with things like EPA's EnviroFacts dataset, the National Map Viewers NHD stream segments, National Inventory of Dams, We have a Colorado abandoned minelands data hub that we work with. We have a copy of CDPHE's macroinvertebrate sampling, as well as their stream segmentation and classification. Become obvious why we need both of those. And then we have a number of other different data sets that handle both local and national scale data sets. CSIP is our Katina compute engine, so that's the acronym over there. We have ones dedicated to just a library for handling water services. So that's data out of USGS, that's data out of EPA, and a few others, like the Colorado Division of Water Resources. We have land use from an LCD. We have climate data from a number of different sources. And we have the actual algorithm itself for the watershed prioritization tool, right? We have to store all the data that I'm going to show you somewhere and front face that to the website that you're interacting with. But enough of the hard parts. What is the non-point source watershed prioritization tool? This one is a dashboard that enables users to explore physiographic and ecohydrologic conditions across Colorado and prioritize them. So the purpose is really, how can you explore what's in your watershed and what can you learn from that? That's really kind of the bare bones. What's there and how does that impact the question that I want to answer, right? What segment of this watershed do I need to go pay attention to for protection, for restoration, for examples of watershed health or examples of poor watershed health or vulnerability across all the different spectrums of different categories of data. Behind the scenes, this dashboard uses a multi-criteria decision analysis, and that'll become clear why, to help with the ranking of all of those disparate data sets and watershed indicators, because we've got, I think, 235 plus indicators built into this dashboard, and to do math by hand on that many, you're never going to rank it. You could try for a couple weeks and you're never going to get to an actual rank of that without automating it in something like an MCDA framework. And that's basically just a weighted ranking scheme, if you want the very simple explanation of what that is. The point of this dashboard is to leverage all that information in the MCDA so that you can do a handful of different workflows. You can do things like the bare bones simple, I want to conduct an EPA Healthy Watershed Assessment. EPA started a Healthy Watershed Assessment framework a few years back so that you could have a framework to compare watershed A against watershed B, despite size differences, despite location differences, despite one end of the country versus the other end of the country. They wanted kind of a uniform framework to go in and assess those watersheds. At a more simple level, you can simply rank the watersheds in your area of interest for protection needs, for restoration needs, or build a custom scenario that says, I ranked them for the things I care about, right? Maybe I care about a different subset than the EPA Healthy Watershed Framework. Maybe I care about a different subset than what CDPHE is defined as protection and restoration needs. But the idea is that you can identify the critical watersheds in a region that need money, need repairs, need protection, need something, need the purpose that you're going to go answer. And then, like I said, you can non-dimensionalize all this and compare watershed 1 to watershed 2, despite watershed 2 being 10 times bigger with 1,000 more people in it than watershed 1, right? You can cross-compare these watersheds against metrics that normalize it, and you're not getting, well, you're not getting a lot of those weighting issues. So the EPA's Healthy Watershed Assessment Framework was developed, and they ran a number of different preliminary healthy watershed assessments around indicators of watershed health and indicators of watershed vulnerability. These are spread across a number of different data categories. You can think of these as some of the more simple, kind of wrap your mind around it. This is landscape condition, it's habitat, it's hydrology, geomorphology, water quality, biologic condition. Those are a lot of the health metrics, right? Natural landscape generally lends itself to a healthier landscape than a very augmented landscape or a very inundated landscape that's been modified for human use. And that usually relates to better biologic condition, better water quality characteristics. Sometimes that's not true, of course. There's site-specific characterizations that are always worth considering. But the idea is to take indices within these categories so that you can come up with a ranking against each of the categories, right? What is the which watershed has the best landscape condition? Which one has the best water quality? Those may not be the same watershed, but you can do the math within each of those categories for a number of different indices and figure out which one's most important. To that end, EPA prescribes a number of different indicators within all of these categories. That's the image on the left, or sorry, on the right. And it's a great starting point. You can think of this as things like percent natural land cover in the watershed, percent natural land cover in the hydraulically active zone, and on down that list. I'm not going to read them all. But the point is that this is a framework. This is a starting point. And what we've done is we've gone ahead and used this framework on the watershed health side of it to keep all of their categories: landscape, hydrology, geomorphology, habitat, biologic condition, and water quality. And then we expanded the list of indicators within these categories, primarily around the hydrology, landscape, and water quality side of it. We looked into many more categories of landscape condition. Not only did we look at natural land condition, we looked at what percent is forest, what percent is urban, what percent is ag land, what percent is rangeland, wetland. There's a whole bunch of different ones in there. You can also look at the water quality side of it. They use a very basic framework for what is the difference between assessed watershed stream length that supports its designated uses and which ones are impaired for those designated uses. We expanded that. We expanded that for a total length of stream miles that are impaired per water quality parameter of interest, right? So that's the 303D list in Colorado, and nationally, of course, but this is specific to Colorado. We also looked at it as which stream segments have TMDLs, which segments are on the M&E list, which segments have a history of water quality, right? You can look at the trend in water quality, and that one's important. So you can think of the non-point source prioritization dashboard as taking this and expanding in the watershed health side of it. We added a number of indicators. We did not add categories. Now, kind of the opposite end of this is watershed vulnerability. This one's much more where we're going and risk oriented. We stuck with the categories and the indicators that EPA suggested, right? So things like land use change, water use, wildfire risk, things like that. But we also added a number of categories here through collaboration with CDPHE. We added a climate change, right? One, what's your trend in total precipitation? What's your trend in temperature? We added a hydrologic change. What's your change in stream flow, right? What's the long-term stream flow in this area look like? Is it generally decreasing? Is it steeply decreasing or increasing? It all varies. You want those numbers to really drive some of them. Then, like I said, we vastly expanded the water quality change side of this. So that includes trends over time. We'll go into the details of how that all gets calculated, but we did an annual trend in water quality for each of the particular water quality parameters of interest. So on the watershed health side, we kept the categories and added indices. On the watershed vulnerability side, we kept the indices and added more categories with more indices into the framework. Now, the cool part is this is all rolled into a dashboard that you can turn on and off the different metrics. That's the fun part. So you'll see a list on the left of the data categories that kind of represent the historic current conditions. These are mostly oriented towards health metrics. You can turn these on or off dynamically or use one of the preloaded EPA Healthy Watershed Framework, the Protection Framework, or the Restoration Framework, or you can do your custom. So you can override any of the, maybe I don't care about wildfire risk, maybe I don't care about annual precipitation. Whichever one suits your needs, you can turn these on and off for your purpose. But the idea is these are the categories that we assessed in there. Similarly, we have the vulnerability side of it for the projected conditions. That's land use, climate change, hydrologic, water quality change, water use, wildfire, the ones we just covered. And again, you can customize which ones of these are active or inactive in your own project, your own assessment to those ends. But the tool itself starts a little bit more simple than that. It says, where do you want to analyze? So if you go to, and I'll share the link at the very end of this, to the non-point source prioritization dashboard from our toolkit, you will go to a landing page. You'll go to the home screen, and then it'll say go to the next page after some instructions, basically. This is that next page where you specify where in Colorado you're interested in assessing. You can draw a polygon. You can select a known boundary. You can pick your city. You can pick your county. You can pick whatever area of interest is meaningful to you. Maybe you want to look at something as big as the South Platte. Maybe you want to look at something as small as Clear Creek, right? Or whatever is useful to your analysis. You specify that with the beginning area of interest, your region. Now, note there's a few different steps in here. So we picked a known boundary. We picked a HUC 6 watershed. Those of you familiar with the HUC system or hydrologic unit codes, it's a product out of USGS for very identifiable watersheds. Consistency more than anything. We picked the South Platte. That's a HUC 6. You'll notice it does extend over into Wyoming and Nebraska, but the point is we're going to assess the ones here in Colorado. And then there's this lovely little toggle that you're probably all asking yourselves, what's that mean? Am I analyzing live data or cache data? So sitting behind this tool for those 235 indicators are algorithms to go convert the data set into that indice, right? If I have a land cover data set, I need to go calculate the percent urban land, the percent forest, percent ag. Well, what's that snapshot of that data? So this tool's in the middle of its QA for its annual update right now. So by the end of this week, we're anticipating that we're going to have the 2025 snapshot of the cache data updated. So that one will be out here shortly. You can run live data anytime that you want. Understand that if you're assessing an area as large as the South Platte, for some of these data sets, it can be very long, and we're talking minutes to hours kind of thing, to extract all of that. So I don't really recommend using the live data query unless you're probably analyzing below the HUC 10 level. Just for speed reasons, you don't want to sit and wait that long. So what you can do after you specify your area of interest and your data type, right? If I want to run the cache data, it's going to return in just a second or two. You get your summary of the watersheds, right? From here, you specify the subregion that you want to rank, right? What are you prioritizing? The list of what? And this tool is kind of built around most of those watershed scales, right? HUC 8s, HUC 10s, HUC 12s. Just for a ballpark, there's about 80 HUC 8s in Colorado. There's about 200, I think, HUC 10s, and then there's 1,400 HUC 12s, something like that. There's a lot of different watershed scales in Colorado. So you can see how many HUC 12s exist in the cache Laputer in Colorado. You'll notice that the ones that extend into Wyoming and Nebraska, those only if they intersect Colorado are they kept, right? We're not ranking any of the watersheds outside of Colorado's jurisdiction, so they're just excluded in this tool. You can do the same thing for counties. Counties is actually simpler because there's not as many as watersheds. But once you've picked your subregion for your prioritization, you get a whole slew of tabs at the bottom of this tool where you can start interacting with that data set, right? So you can see as I have selected Spring Creek at the bottom, you can review all of the different indicators. And these are grouped by those categories that we talked about earlier. We're going to go into a little bit more detail, but you can see that you've got landscape condition, you've got your natural land cover and its associated units, you've got your natural land cover in the hydraulically active zone and its associated units, population density, the count of abandoned mine land features, the density of abandoned mine land features. Those are both kind of pertinent to a water quality side up in the mountains around here. And you can see all the different tabs summarized in here. So the first one is just purely what are the numbers. Watershed overview, water quality overview, and impairments in TMDL are a whole different structure of summary. Those ones allow you to select one of your subregions and compare it against both the data set and the state. So if I pick that same Spring Creek subwatershed in the South Platte, I can go through and look across my watershed conditions, my watershed overview. I can go look at all of the different metrics. So you'll see that this is quite a dense graph because across those three tabs is the 235 indicators, but you'll see a number of different ranges. The green dot is the subregion that you've selected. So up at the top left, you can change which one that is. And you can see where that lands in the range of data. So if we took something as simple to understand as average annual precipitation, kind of the middle there, you'll notice for Spring Creek, we're kind of at the low end of typical precipitation for the gray bar and the blue bar. What are the gray bar and the blue bar? The blue bar is the other watersheds that you've selected, right? So the rest of this entire set of watersheds, the min-max range on those watersheds dictates that blue bar. The gray bar represents what exists throughout the entire state. Right, so which watershed, what's the min for any HUC 12 watershed in the state of Colorado? What's the max for any HUC 12 watershed in the state of Colorado? So you can see Spring Creek tends to be on the low end of the selected watersheds and the low end of the total watersheds. This varies by parameter, of course. You can get the watershed conditions summary and the watershed overview. Water quality is specific to water quality, right? That's trend, that's annual concentration of water quality. That's count of impairments in TMDL is count of stream miles and impairment types by parameters, right? Which one's impaired for nitrogen, which one's impaired for E. coli, which one's impaired for sediment, and which one has TMDLs for different areas of interest. You can specify and walk through any number of these. And they all look fantastically similar, but it's a completely different data set because you don't want to scroll through 230 indices. Those are kind of the three sections there. The next step of this is, okay, how do I reconcile the 235 plus indicators that are available in the tool, and how do I do something with them mathematically to turn that into something I understand, human digestible? What action do I take for the priority watershed? How do I calculate that? So we implement what is referred to as a multi-criteria decision analysis that uses categories and indicators. And you can weight both the indicators and the categories, right? So maybe water quality as a whole is more important than landscape surface, right? Land use. Or maybe a particular indicator like my arsenic concentration is more important than my dissolved oxygen concentration. You can weight the indicator within a category differently than the category amongst the other categories. An example of this is kind of listed below there. Land use change is a category. There are a number of indicators within that land use: change in cropland, change in impervious cover, and change in human use, right? Human use of water is the example there. We can go back to the big list of those if you want. But the idea is, how do you take those indicators, right? Watershed 1 has so much cropland and it changed X% over time. Watershed 2 has similar numbers, but different outcome. How do you group those at the indicator level into the category and the category to the total? And that allows us, by normalizing all of these indicators against each other, to create what is referred to as a relative watershed condition. So this allows you to then rank those watersheds based on the category, based on the grouping of category, watershed health, watershed vulnerability, and as a total, right? All of them combined. And that's where you get the power of this tool, that you can get the whole scale. My watershed is most important, but you can also dissect the category level rankings. Which ones are the natural land cover ones that I care about, right? Where are the best land uses? Where are the worst land uses? Where are the best climate? Where's the worst climate? You can go look at those. An example of that's over here on the right. So you'll notice landscape condition is one of the categories. It has a relative weight bar just below that, right? So relative ranks of 1, 2, 3, 4. They're non-dimensional. They get normalized against each other, so there's no issue there. But an MCDA framework allows fractional based weightings if you really wanted to get to that level of granularity. And then the list of indicators within there, right? So under landscape condition, we have natural land cover, we have population density, abandoned mine land features, active mine features, developed area, agricultural area, forest area, public land, tribal land, etc. And it keeps going. But the point is, each one of these can, and it's staying on the image on the left, you can rank the indicator amongst itself, right? So you notice land cover is ranked with a 4. Natural land cover within the hydraulically active zone, also a 4. Population density, also a 4. Abandoned mine land features, also a 4. You can override those. Each one of those is preset under, going to the left side of it now, the different analysis methods that you're going to pick, right? Am I going to pick the EPA Healthy Watershed? Am I going to pick restoration? I'm going to pick protection. Each one of those has a default weighting scheme. The EPA Healthy Watershed is purely a 100% ranking of the same indicators within it that we walked through. Protection and restoration was calibrated by collaboration with CDPHE staff. So that's got a different weighting scheme that lends itself towards the non-point source prioritization for the state. So the non-point source pollution group at the Water Quality Control Division has a number of things that they looked for. That's the weighting that's defaulted into those. You'll notice, going back to the right side, you can also change whether you want to maximize or minimize a particular indicator, right? Is good maximizing this indicator or minimizing this indicator? Obvious example would be natural land cover versus mining features, right? If I'm thinking about watershed health, the more natural land cover there is, that's probably better for it to be healthier. Less of the watershed is modified in a bad way. So maximizing natural land cover has an up arrow. It's maximized. Abandoned mine land features, that one has a minimize. It's negative, right? The more mining that's taken place in this area, and we're talking the 1800s and the early 1900s for most of that framework in Colorado, you want to minimize most of those because it means that there was unmitigated rock piles and acid mine drainage and all the things associated with we didn't know better at the time. because that was a very long time ago. But you can override these, right? Maybe for your analysis, you care more about the minimization of forested area because you want to find where you can do something else. You want to do open rangeland or something. You can prioritize. You can use this tool to prioritize other topics and other uses. But the point is, this tool comes with 3 default methods for analyzing it: the EPA Healthy Watersheds Framework, the CDPHE protection, and the CDPHE restoration frameworks. Those are the 3 that are defaulted into here. You can also go in and override these, right? So if I go in and override a whole bunch of stuff on the right side, you'll notice it's the same list, but I've turned on and off a few more of these, right? I've turned on developed area, I've turned on active mining permits, I've turned off a couple, and I've changed all the weightings. This was originally based on the restore category. You'll notice there's a little asterisk next to that in the interface this time. It basically highlights you're doing a restore scenario, but you've overridden what those weights are. It's not the default run of a restore analysis. It's not the default run of the EPA Healthy Watersheds analysis. And it'll summarize that in the results page, that it's a user custom restore scenario to be interpreted that way. But basically, it lets you get apples to apples comparisons of, did somebody run the default that's in here if they're turning in a report, or did somebody turn in a different answer? So you can customize this to your heart's content. We could walk through a few of these examples at the end of this if that's of interest in the live tool. Happy to demo that if you've got some questions. But the point is, once you run that, you get the output that I teased you with at the beginning, right? For my EPA Healthy Watersheds assessment of the South Platte that I showed you at the beginning, which are the healthy watersheds? Which are the poor watersheds on the health side of it? You'll notice that in addition to the watershed data, the watershed overview, water quality overview, impairments, and TMDL, there's a couple more tabs on the right side of this. MCDA inputs, that's literally just a copy paste of what you clicked on the left side, right? Which one of these indicators were active? Was it minimized? What was the relative ranking? It's a carbon copy of what did you click when you clicked run, so that you can come back and pick up where you left off if you want to reanalyze something. If you want to hand this to your coworker and say, I understand this result, can you like reanalyze this framework, this method in a different place, right? I want a different subset of watersheds. You can have that input output transparency. The MCDA results tab, like I said, is broken down when you do the EPA Healthy Watersheds. You have your overall rank and your score. Score is kind of a meaningless number. I think it's like a 1 to 5, if I remember correctly, or 1 to 2. But rank is the relative rank against all the rest of the watersheds, right? So Spring Creek ended up 312. That's not one of the better watersheds in the overall Healthy Watershed rank. You also notice that there's those same categories, rank and score, for the sub-indicators, right? So for the Healthy Watershed metric, we had the total, and we had a health category, or a health meta category, and a vulnerability meta category, right? That was kind of a below the top of the analysis, right? I don't care just about the 312, but I also care about which watersheds are genuinely healthy. Well, Spring Creek ranks an 8 on that one. So it's one of the healthier watersheds, but it's not all that vulnerable. Or it is vulnerable, sorry. 466. So it is one of the more vulnerable watersheds, which is pretty poor. So you can get that level of results. You can also go through and run this for the different scenarios, and you can see the composite score, the health score, the vulnerability score, rerun the protection side of it, rerun the restoration side of it, and you can get that score across all of these, right? So I've got, this example is run for 2 watersheds, so the ranks and scores don't change all that much. But the point is, as you run more than one analysis, you can compare these against each other, right? So your first run, MCDA number 1, was an EPA Healthy Watershed Assessment. MCDA 2 was a protection. MCDA 3 was a restore. You could have a 4th that was a custom. You can compare against each other the default prioritization versus your custom prioritization, what matters to you, and you can see how much that differs or changes the outcome of which watersheds are important or not. How all this matters, taking a step back, we had to make sure all this was accurate, right? In order to provide confidence in the prioritization dashboard, we had to go through and prove the calculations. We had to prove the data quality. We had to prove the pass-through of, we took these indicators, grouped them in these subcategories, and matched something. Well, what was that something? So we went through an intensive, I think there was like 6 or 8 months of QA/QC with CDPHE that we dedicated to making sure when a one-to-one comparison on the analysis that we were performing. To our luck, or not so much luck as to our benefit, EPA had selected Colorado among the states in the nation for a preliminary health of watershed assessment. So they had a data set per HUC 12 watershed with the associated indicators, and we could take their input, run it through our algorithm, and compare it to their output. So it was a literal one-to-one, right? It wasn't whether or not our data was newer. We could take their data one by one and replace it and run it in this tool. And we did. And what we ended up with was 100% match, which was just wonderful because we got the same answer for the same reason on the same data set as they did. We also, because the snapshot from the preliminary health of watershed assessment, which was 10, 15 years old, is not all that recent, we did an internal QA with AUSI here at CSU, where we did a statewide assessment and did some spot checks on the data quality and the pass-through. So we took a watershed and calculated the natural land cover, and then we did it by hand. We calculated the natural land cover, and we did that end to end for every one of those 235 metrics, which was tedious. So there's a lot of spreadsheets involved in that for comparing the outputs. But the point is, the algorithm is the same. We match the same output as what the preliminary health and watershed assessment framework does, and the data quality is the same, despite the data being newer, right? So the 15-year-old preliminary healthy watershed data is not what's available in this tool. The much newer version is what's available in this tool. And like I said, by the end of this week, we'll be transitioning that into the 2025 snapshot, which will be a lot nicer. We also turned that over to CDPHE. They did a whole review internally of it. We handed them the data set, we handed them the outcomes, we handed them the algorithm. They QA'd the heck out of the interface too, and the data set and the answers that matched both outside of this tool, rankings and prioritization, ground truth knowledge, and a few other things to spot check and have confidence in this whole system. The tool itself is located at npspd.erams.com. Like I said, ERAMS is kind of our online web presence for all of our dashboards. So we threw the acronym in front of that, and that's kind of a landing page for the tool. If you want some documentation for how to use this tool, that's things like a user guide, that's things like a quick start, that's things like a video, which is mostly me and Sarah rambling on about how to use this tool. You can go to the second link, which is erams.com/Katina. /tools, Colorado Collaborative Watershed Prioritization. If you don't remember any of that, just go to erams.com and go look for our tools. There's a software portfolio list that you can go into and you can find the watershed prioritization tool. The point is that that one serves as kind of the big starting point of this is the tool. This is a video tutorial of how to walk through it and digest the answers. This is a user manual that says, okay, what's the data source on this particular item? What's the data quality? What's the timestamp? All those fun things that are built into it. We have a number of software resources. We've got the user guides, the instructional videos. We're doing these webinars. Housy's also working on some technical assistance and training programs to get people more proficient in our softwares to the benefit of various groups in Colorado, like CDPHE and others. So these resources are going to be ongoing into the future. Don't think that just because this webinar is over, you can't reach back out to us and say, hey, I forgot how to this. No, please reach out. The point is that we're here as a resource for the software that we've put together. To that point, I'd like to thank you for the kind of the canned approach. I got done in about 35 minutes. That's kind of the target I wanted. And we've got about 10, 15 minutes dedicated to, do you want to do a demo? Do you want to do some hands-on questions? I know the QA has been filling up. I've been kind of keeping an eye on that monitor that's got that list in there. But I will open it at this point. Sarah, if you want to provide a kind of quick summary of where we're at on the QA and if we want to move into a demo.
Sure. Thank you, Tyler. I am not seeing anything in the QA. So Tyler, if you're seeing questions, that means I'm not. I have the chat open as well. I did put on some of the links that Tyler referred to, both the tool landing page. That website will also open up our calendar of events so you can stay up to date on all of our different activities. And I also threw in a link in the chat to our LinkedIn page. We're getting really active on that. So all of our upcoming trainings and activities are posted there as well. So consider following us there. Any questions at this time? Feel free to raise your hands or throw it in the Q&A.
And if you don't, what I'm planning next is we'll go through an actual walkthrough of an example so you can see the live version of all this instead of the canned screenshot. I think Kanan had his hand up first, Sarah, if you want to unmute him.
Yes.
Then it looks like Mark's got a question after that.
Okay, Kanan, you
Uh,
should be able to turn your mic on now.
yeah, sounds good. Thanks, Tyler. I think you remembered the things we have done about this a lot better than I would have. But one thing I want to say in here is if you look at the Healthy Watershed document from EPA, and if you try to repeat it and get exactly what they published, like Tyler was talking about for Colorado, you won't be able to.
You got to go way
Because,
back and get a copy of the input data because their watershed math is their what was a land use was a very old timestamp.
yeah, the one of the things also they left out from the document is some statistics at the time I didn't even know existed. I think it is called winterization or something like that. So we had to go through several testing. We were not getting the results that they were publishing. They published. So finally, we realized that option was left out from the document we were following. So that drove us to EPA, then EPA's consultant to be able to add that process, figure out what that process was, and then add that process to be able to get the, I think our results were like 90, don't quote me on it, this is 5-6 years ago, 96% match with what they came up with. But just heads up, if you are following EPA's published document for healthy watersheds, you don't really get what you really should be getting. This model will allow you to get what you want. I just wanted to comment on that.
No, that's a great clarification. Kanan, like it said, they basically have some undocumented methodology steps in there that you've got to reach out to them and get a clarification on how to do it if you were to try and do this by hand outside of the tool. So if you want a one-to-one, this tool will do it. That's the good part. Kanan, I think the number that sticks in my mind was 96%. I was looking at that spreadsheet last week to pull that statistic, but I think 96 is what we had as far as the overlap. And you're absolutely right. This tool rolled out in spring of 2020, going into COVID, is about how old this particular tool is. So it's definitely been a journey since then to get a lot of adoption going. Mark, do you want to go ahead next if Sarah can unmute you?
Yeah, Mark, you should have mic control, so you can unmute yourself now, hopefully.
Okay. I just clicked on the event calendar and it opens up to December 1899. So I don't know. I would love to just subscribe to the emails or the meeting notices for these webinars, but I don't know if that's what you intended, I guess.
That's a good clarification. I don't think that's what she intended. If that's the behavior it's getting, we'll go ahead and dust off and send a cleaned up notice. You guys will also, just as a side note for the webinar, you guys will get access to a copy of this recording. So if you forget anything or, oh, he said something at that point and I forgot what it was, you can go back and watch this, right? The whole point of being a member in this webinar is that you guys have access to all those resources, documentation. If it's okay with you guys, I'm going to go ahead and pull up a link to that tool and walk you through a little bit of a live demo if that's something of interest to you guys. Actually, probably of more interest. If you start off at erams.com, you're going to end up here. This is our documentation site. It's getting cleaned up. CSU's making us adhere to their brand standards here in a moment. But under our software portfolio and the Colorado water systems, this is the Colorado water systems selection, you can find the watershed prioritization tool. And that's going to give you that same link that Sarah put into the chat for the non-point source prioritization dashboard. This gives a little overview of why do you care, right? Look, it's an MCDA. It follows the EPA Healthy Watershed Assessment framework. It does what? You've got the link to the user guide. That's a PDF. I got a link to the tool itself. That's the one that we already shared, the npspd.erams.com. You've got a little quick start, kind of why do you use this dashboard, as well as the webinar training information for this one. So if I follow that launch, it'll take you to a new tab, give you a little pop-up. If you got any follow-up questions, follow up with CDPHE, and then you're into the tool proper. All of our tools kind of have this integrated landing page that gives you a little overview of what it is. You can go to the next step in the tool. This is kind of a linear set of steps that you can review, and you can pick your area of interest, right? So if I wanted to, we're up in Fort Collins. We like Fort Collins and the Cache-la-Poudre River. So if I want to zoom in over here and say, I want to go get the Cache-la-Poudre River, which I know is a Huck 8, I can go grab the Cache-la-Poudre as my area of interest of a watershed. I'm going to stick with the cache data set because we don't want to sit there and wait that long. And I want to analyze Huck 12s within it. It's going to go fetch that real time from the data cache and then come back with these are the 235 metrics that you've got. You can interact on the map and figure out which watershed's which, right? So that one's the outlet of the river. This one's Coalbank Creek. That one's Rawhide, right? So you can go through and you can figure out, you can orient yourself, okay, based on the map, based on the table, you can go ahead and review the data sets. This bottom panel is collapsible and expandable. You can get it all the way and just have a map, part way and have both. You can click and drag if you want a little bit more or a little bit less. It's all responsive. That's part of the whole joy of online web tools. Or if you want to just look at the big set of data, right? I've got all my different summaries here. I've got 2-3 pages of this, and I can scroll through all of the 230 metrics that we have for all of these watersheds. And these are all broken down by category, right? So you have your natural landscape condition, natural land cover, population density, abandoned mineland features, all the way down to the other ones. All right, so if I hop down to some of the later ones, I got my climate change in total in snow relative to precipitation ratio. That's mostly a mountainous watershed, so you're going to see a lot of no data down here on the plains. Change in annual precipitation, right? So that's how much change in water you get per year based on the observed trends. Temperature, same thing. But you've got all of the different metrics and all of their different data sets that you can summarize there. You can go to the watershed overview section and get this interactive graph, right? So I've got my statewide bars, I've got my subset of those that are within my watershed, and then the one that I've got selected. If I don't want to look at Coalbank Creek, I want to go look at Horsetooth Reservoir, right? And I can go pick another one of my little green dot moves. That one, that's a good metric, actually. The reason that one moved to the upper end of the metric is Horsetooth Reservoir Huck 12 watershed contains Horsetooth reservoirs, which is the largest reservoir in the Cache-la-Poudre River system. So of course it's at the upper end of the dam storage in millions of gallons because it's the biggest reservoir in the watershed. That makes exact sense. These are interactive. You'll notice that most of these have varying scales. So you can zoom in on any of these. You can click and drag across this. So you can zoom in on a subset of these to whatever area is interesting for yours, right? I can look at my change in human use. Some watersheds have seen a decrease. Some watersheds have seen an increase. And all the rest. You can zoom back out. You can do the same thing on the water quality side of it. What are my water quality conditions? There's a number of these that just don't have data because there wasn't monitoring data for a number of these within the period that we wanted to cache. You can do the same thing for miles of impairment, right? So you can either look at miles of impairment or count of impairment, right? By category, right? How much do I care about nutrient impairment versus sediment impairment versus some of the others? And again, these are all interactive that you can zoom in. This particular watershed's at the low end, doesn't have a lot of issues, but you can go up through the chain. You can say, okay, what if I wanted to look at a good one? I know in town, you notice that there is impairment for some of the other parameters in those subsets. Again, if you want to look at the interactive side of it, MCDA inputs, mostly empty because you haven't run the analysis yet. MCDA results, also empty. You haven't run the analysis. The detailed results, also empty. You haven't run it. You can go through, click the next step, or you can click this one, this section of the tool, and this is going to give you the access to the overall pick your analysis method, right? Do I care about finding healthy watersheds? Do I care about finding watersheds that need protection? Do I care about finding watersheds that need restoration? And you can pick and override as many of these categories as you want, right? Do I care about the Shannon Diversity Index of macroinvertebrates? Do I care about my change in human use category of land cover from 2011, 2016, and that's going to get updated in 2025 here in a little bit. Change in peak discharge, change in low flow conditions, change in average annual outlet at the watershed outlet. There's a whole bunch of these. You can override and run as many of them as you want. I'll run it just for the sake of showing you. I'll get my ranking of my watersheds. You notice that's real-time fast. That's the whole point, is that this is a quick analysis. It gives you, walking through the summary side, the inputs is literally just a copy paste of this is each indicator, right? Natural land cover has population density. So 1-for-1 all the way down the list, whether or not you have it turned on or off, what was the weighting for that category, and whether you're minimizing it or maximizing it. This is kind of an apples to apples. You can run the same analysis as the data changes over time, right? You could keep this snapshot and go run it against the live data set, or the 2025 one that comes out in a week. You can also see the results, right? So Cold Bank, these are all sortable, by the way. So the healthiest watershed is North Fork of Lone Pine Creek with a rank of 1. The healthiest watershed, right? So this is the overall rank. The healthiest watershed was Joe Wright Creek, which is up at the headwaters. Makes a little bit of sense. The most vulnerable is Cold Bank Creek. Least vulnerable. I need to check the documentation on that one. But you can interact with these and see those summaries. You can also see the per category results, right? Maybe I only really care about which ones have good landscape. Well, the headwaters of headwaters of the South Fork of the Cache-la-Butte River has the best landscape condition. That makes sense. That's up in the headwaters. That isn't a lot of modification. Which one has the best habitat? Which one has the best biologic condition? Which one has the best change in climate? Which one has the best change in land use? You can go review all of those. For all those different subcategories, you can get the summaries of which one is my best hydrologic one. What's in hydrologic? Go look at hydrology and see what it is. Ag on hydric soils, dam storage, most amount of forest, most amount of wetlands, least amount of impervious cover, least amount of road stream crossings. There's a few others you can turn on if you really wanted to. So you can review all of these parts. You can also, because this is a web tool, I don't want to have to come back to this. Sometimes it's nice to have the snapshot. You can download the content of this to a report that's going to pop up. I got a little PDF that gets generated out of this tool. Go show you what that one is. But you've got a snapshot of your watershed, exactly how your map was. So if you were to take your map and zoom in, like if I were to zoom in to just this particular watershed all the way down to Halligan Reservoir, it'll take the map screenshot there and then put it into the PDF. It's also got a summary of the MCDA overall for your list of watersheds. It's got the detailed results per category, right? Landscape condition, climate, hydrology, etc. Then it's got the actual raw data itself, right? So this is the data side of it. So what is Cold Bank Creek's natural land cover? 53% natural land cover, and all the way down. So you've got a carbon copy that's external to the tool that you can go take this and put it into a report, as big or as small as you want from your snapshot. You can download that content out of the tool for use elsewhere. Given my quick live demo, I'm happy to analyze your question somewhere else. Maybe you don't care about the vast majority of these. Maybe you want to go run a one-off that just says, where are the road stream crossings the worst in Colorado? We could run that live now if you have a question like that, or anything else that's kind of popped in your mind since we've been doing that demo. But go ahead and raise your hands with any questions. Otherwise, we'll bid you adieu and hope to see you guys next time at our next OWSI webinar, which I believe is in 4 weeks. 3 or 4 weeks, and we're going to be doing a flood analysis tool that we've developed with Forest Service.